Hey there, this is Debesh, the info security researcher. Today is Saturday, and I am here again with another episode of Tech Podcast. Today's topic is on building interpretable AI solutions, and the guest speaker is Srijit Mukherjee, who is an AI researcher working at the Penn State University now. Without much ado, let us bring the guest on the screen.
Hi
Hi,
everyone.
hi,
Take my
Srijit.
pranam
Yes,
to everyone.
thank you for
Yes.
agreeing to be a guest and expose yourself live. And and the start, I always ask my guests to tell about themselves. Like you can say the pitch, who you are and what you do. So what you want that you are, people know briefly, please.
Oh, okay. Um, I am currently pursuing my PhD in medical AI at Penn State University, as Dr. Chaudhury has introduced myself. And I would say I would just call myself that. I will just like to introduce myself in that way. But the only thing I will add is that I just my work is not just normal AI. I plan to build interpretable AI solutions. The reason is simple that if I'm working with doctors in the real field and building something for the doctors, it should be interpretable that they can use. So that is the extra line I would add
Yes,
to myself. That's it. My not
yes,
to my
it
work.
is interesting, and I have seen in your LinkedIn profile that you have struck out that random and interpretable. So, what is random AI and why how it is interpretable? I mean, what is the difference you wanted to mention by that cutting that?
Oh, oh, again, that's a good question. So random AI is when you pick up now all these tools are available online, right? Using well-written codes. When you pick up one of them, not like it's not like you do not understand that you understand, but that and you pick up a certain tool, but you do not know what that tool is doing. Okay, it's like picking up a book without knowing what you want to learn. Uh, that may give you some knowledge, but your goal may not be fulfilled. So, similarly, you have to have an understanding of what you're building all for this problem that at hand. So, that's when I said random. It's not like random out of yeah, it's not like random out of the blue. It's like random which you do not know why you are doing it. That's the whole meaning of striking out the
Okay,
random thing.
so it gives some specification. So, what is now just before starting your actual research work, which we want to know briefly, but say this there are so many AI platforms. So, are they giving their solution is random or interpretable? Like say the well-known ChatGPT, DeepSeek, whatever are there.
Yes, so that's a good question. I would say there is an aspect of interpretability there. Um, okay, so let's break down into simpler pieces. And I always like to compare AI with teaching a child. Okay, just like
Yes,
a child's brain, an AI brain or the neural network is also
yes,
devoid of notion. And there's a
yes.
something called transfer learning where um, you are using the past training to update the training weights for new data. And I would like to call that in Darwin's language the evolution. Okay, it's like you are storing in the brain of the past memory the evolution of, so it's like human beings evolution of or neural networks evolution of past knowledge of how they were trained. So in that sense, um, nowadays since those previous networks are being understood step by step, and it's turning out they understand what humans wants to understand. In some sense, it's interpretable. But also, I will add another aspect to that, that when you teach a child or when you learn something, if you learn too much, okay, you will actually do this problem at hand. You will solve the problem at hand if you learn too much without understanding, right? We can solve problems from the back of a math book by solving too many problems
Yes.
without understanding, right? If we
Yes.
just know the method. So that's why you have to, when you define interpretable, you have to actually define carefully that what that means when you use the term interpretable. Is it just like, can you solve the problem at hand with high accuracy? Then ChatGPT is doing really well. Okay, all of them are doing really well. But if you want to understand that what exactly it is doing, so I will talk to you about a paper published recently where they trained a model, a transformer model, on basic modular arithmetic. Okay, it's like, yeah, it's an arithmetic. Okay, modular arithmetic. If I explain in simple language, let's say 5 plus 7 is 12, right? But when you say 5 plus 7 with respect to, let's say, 5, then the remainder is actually 2. So 5 plus 7 is equal to 2 modulo 5. So this, when you build this algebra up, this is modular arithmetic. I think, yeah, any cryptographic background person will know this. It's
Yes. Yes.
so there was a paper of where they were training the neural network, a small neural network, on this data set, and they wanted to understand that, is the neural network really learning what we are learning? Like, we are human beings learning in this specific remainder way, but how the is the neural network learning? And when they did that, there is this famous person, Neil Nanda. He's right now at Google. So now all the big companies have interpretability teams, mechanistic interpretability, where they try to understand what happens in each of those neurons or a group of neurons features. And they found out that it is not doing the way we are doing. And there is a very interesting reason to that. How neural networks are designed are by something called also positional encoding, okay, which is nothing but a sinusoidal curve. Now, if you think carefully, the sinusoidal curve also has a periodic habit, just like the modular arithmetic. So what neural network is learning is via the sinusoidal curve, the relationship of the modular arithmetic, which human beings are not trained to do. But essentially, it's doing the mathematics right. This is one example of mathematics. Let me give you another example. This is a beautiful example. So there's a professor, David Bow at MIT. So he is trying to understand in vision, like computer vision.
Yes.
And he trained a model, generative adversarial network GAN, on generating lighting brightness of the whole room. Okay. And the researcher team found out this beautiful property that after training, that if you turn off or if you reduce the activation on the neuron, a certain neuron, down, or increase the activation, it's just a number, right? Increase or decrease. The light of the room is turning down and up.
Okay.
So what we're trying to understand is that we are, so what human beings have not been able to do is that we do not know how, what our neurons are doing.
Yes.
What we are trying to do is, what interpretability is all about is, okay, we cannot understand this complex brain, but we try to mimic it in our artificial way. Let's at least understand that. That is what we at least need to do. This is basic. We are
Yes.
building something, we should
Yes.
understand that. We
Yes.
didn't build this brain, probably we'll never understand that, but we will
Yes.
building this thing. So that's
Yes.
the whole idea of this interpretability thing, that at least we should understand these large models that we are building.
A fractional part of the brain.
Yes, yeah, it's like a very fractional part of the brain, but it does its job when it's what's needed. So I think the whole philosophy, or the why we are doing it, is, according to me, is at least we should understand what human beings are creating, okay, with their own hands, with their own data that is available around. That is at least the basic thing we can do, and I believe, my heart tells me that this process will actually help us understand what's happening inside our own brain, because it's kind of mimicking that. So we
Yes.
have an approximate understanding what our brain does. Anyway, this whole neural network is built from the brain structure. So I have a book called Deep Learning Revolution by Terry Sejnowski. He's a neuroscientist. He's at Salk Institute right now. So he, along with Geoffrey Hinton and other people, have built this deep learning from scratch. So for example, vision, when you see convolutional neural network, they're actually, they are in a like a deep, this whole idea of deep, that is came from this idea that our human beings, when I see you, Dr. Chaudhary, there's an image that goes to the front part, and then sequentially it goes and it becomes more abstract in the brain. Similarly, the whole convolutional neural network is being built. It's a sequential deep manner, one step by step. So already there is a domain knowledge of the brain incorporated in these deep learning networks. Okay, but we wanted more naturally. So that's the whole idea of interpretability according to my notion. And I do not work in language, so I'm working in the vision interpretability. There is a lot of work has been done, um, but um, yeah, there's a lot of work has been done. I'm trying to apply that knowledge to the medical AI community. So let me give you one small example.
Yes.
You were telling me about this cataract detection. We were just talking before the starting of the meet. So let me tell you the problem so to understand, the viewers understand. So essentially, in a village, there is a hospital, non-profit hospital, and they have a bus, and the bus carries villagers all over the village. It's around 200 kilometers. Whenever they go over the village, pick up the villagers, take them to a camp, do their cataract detection, and then come back. So naturally, they want to reduce this process by, so that the villagers, let's say, I have a cataract. My parents, my wife, my son, daughter, they can take a picture. Sister, brother, they can take a picture and send it to the doctors at non-rhythm, and they can use AI to analyze that. They fasten up the process, and with doctor's intervention,
Yes.
and then they take decision that who needs to have surgery. Okay.
Okay.
Now, different grades are there, right, of
Mm.
cataract. So I try to use the data and understand, and try to randomly build an AI model. Okay, that's what I am saying. Randomly, I took ResNet. Let's say the whole process was predicting whether it's cataract or not. It's a classification problem in machine learning
Okay.
language. And you take a basic ResNet 18, let's say, and you train on the data set. And I found out that it was giving me 95% accuracy, which
I
I was
see.
like, wow. But I don't know why. So I used my interpretability methods to understand to what is it looking at? Is it like, what is it looking at? That's natural, right? We human beings are very curious. Uh, that's what sets it up apart from other animals. Okay, let's not digress. So I realized that when I drew the class activation map, I will show you some examples. I realized that the model was not looking into the lens region, which was the main cataract, where the cataract actually we understand. It's not
Yes.
outside the. It was looking everywhere except the lens. And I was
Okay.
very curious, why? Where is it looking at? It was over the eyebrows, over the skin here. And I realized that the normal patients we have, they are not villagers. They are from the region who are working in the office under the shade, and the villagers are working outside.
Outside.
So villagers have a darker skin.
Yes.
So the cataract people also are having actual darker skin in the data.
Yes. Yes.
So it was focusing on the skin because the skin has darker region, darker melatonin, like darker skin color than the
Yes.
normal patients, normal
Yes.
people, because who they are inside the room. So
Yes.
they were actually looking at the color of the skin, not the cataract. So there are
Oh.
inevitable biases in the data that we don't know.
Oh.
Okay. So this is why interpretability is very important.
No, but when they interpret, because they focus on the skin color, so how that actually correlates with cataract? As you
Doesn't
are saying that,
correlate.
doesn't correlate, but it recognizes the 90%, 90 more than 90%
Yes. Why
accuracy.
is that? Because that's a very good question. Why is that? That's the whole idea of interpretability. Because the computer doesn't know that this is cataract, right?
Okay.
Computers are looking into features.
Hmm.
How they're doing it? They're looking into features from cataract. They're looking into features from normal people, and they're looking into features that are easy because
Easy to
everyone
grab.
is
Yes.
lazy, including
Yes.
computers.
Yes.
So, and what is the easiest feature in an image? The colors.
Colors. Yes.
So they're looking that, oh, in this case they're darker colors. Okay, so low intensity of red, blue, and green, probably low intensity, high intensity of red, because they have more melatonin, and low intensity of blue and green.
Yes.
And in normal patients it's different, right? So they're using that features, not the cataract features. Do you see the point? Now we do not have that control over that resnet, right? It's already pre-built, and the whole structure is there, but it's solving the problem and giving good accuracy. So good accuracy is not about, so that's why we want to understand what features they're actually extracting, okay, that are clinically important when you're actually doing in medical imaging scenario.
And say when you obstruct the portion of the eye and give only the view of the lens position from the
Yes,
image, what is the result?
very
Have you
good.
seen?
So that's exactly what we did next. So that's natural progress, right? uh, that if the pupil is the only important thing, let's give the pupil, and then also we got 15.5%, 98%. But at least this one is interpretable, this one is not, although both are giving the same accuracy.
Okay.
Do you see the point?
No, there
It's
was
about,
no difference.
no, there was
Obstructing.
naturally no difference, because in some patients it's not understanding. But again, you can make more detailed things. For example, now where can
No,
AI like,
or say there was no like total resources used, the time consumed for the result when you reduce the area.
I didn't get you.
Now, the interpretation computational process takes some time.
Yes.
Time for
Yeah.
computation. So when you give only the pupil region, uh, naturally it should take less time.
Yeah, so that doesn't really make much of a difference, because we are only focusing on the inference. Training will anyway take time,
Okay.
because we do not account, because it's only in the inference phase that matters. But you're right, it'll, the image
The total
reduction will
data,
be also,
data points are less,
yes,
which they
that I
want to
fully agree
interpret.
with that. But interpretability has nothing to do with that. It
Okay.
has with do with the computations. But
Okay.
you're absolutely right. Yes, I agree with that.
Okay.
But yes, so that's how you proceed, right? So then you can incorporate features like in cataract, there is more, it's opaque in the lens, right? So you can have opaque detections, right? Opaque detections. Now what happens, why are these big models doing so well? Because they are trained on billions and billions of data.
Data,
So
yes.
it's naturally to understand the
The
intricacies.
tolerance is better.
Yes, naturally, that's I said that you can give train a student with a lot of examples, and that person will actually do well in the
Yes,
examinations.
yes, yes.
Yeah, but that person actually may not understand what's happening
Yes,
underneath,
yes, yes, yes.
right? So that's exactly what the issue is with AI, when you train with large amount of data. But since I work in academia, there is not much availability of data, and it will not be ever happening to everyone, right? So this is a way to also work with low data scenario, that you build models that pertains to small data scenario, and you have to build, you can use AI. For example, in that cataract detection thing, I use segment anything, which is the largest segmentation model right now, best, to get the cataract detection out there. Okay. So do you want to see an example, a demo?
Yes, yes, of course. And now you can share your presentation. Yes,
Yes. So I want to show you a demo of segment anything.
yes.
It's a pre-trained model. It's
Okay,
by Meta, and there's a demo. Let's say.
okay.
So let me download a cataract image. Let me download this person's cataract. And upload it here. So it's first embedding the image
Okay.
features. And now what you can do is that you can have a box. You can use this box. It selects the
Yes.
cataract region, the
Yeah.
lens, sorry. Okay. So now you can extract these features out there, and now to make it more medically viable, you can extract that what is the parameter of what how much opaque it is.
Yes.
Okay, you can
Yes.
extract that. So you can have multiple layers with it, and to do that you need to go back to the basic image processing and
Yes.
computation. So it's a mix of that. So you are collecting information. It's like if you want to do interpretable AI, like for an application point of view, you have to have a good balance of really well pre-trained foundation models like segment anything and a good image extraction feature. That's what I do in my Professor Monga's lab. Okay, I work I mean all many students work under him, so essentially that's what our research idea is, and that's very valuable, I would must say, because mostly also in small research groups where data is not so much available. uh, that's natural, right? So that's how I believe that a large portion of the community will work in the future also. So you need to understand the basics also. Okay, so let me give an understanding. I will also give an example of uh, I will also give an example of another interpretable AI solutions. So there was a chest X-ray scan. People were understanding whether there is COVID or not. Let's say, I'm not sure, but let's the
Okay.
classification problem from chest X-ray images, and they found out that it also giving high accuracy 95%, but it was because in the diseased patients there was a metal out here in the
Oh. Oh.
X-ray. So it was detecting that because it's an
Yes.
easy
Yes.
feature,
Yes.
easily detectable, right? So the natural step is that just hide that, okay, or remove that. So once you learn the method to understand what it's learning and you find out there's an error, the biases, then you can remove the
Yes.
biases, right? So this is what is called shortcut learning. Just like human beings take shortcut, machines also should take shortcut. Okay, because the whole idea is the same. There's a laziness factor, which is the loss function. Okay, so it looks for global optima, which is easily available features, right? So that's how we understand interpretable. That's how you build interpretable AI solutions, which means that there are two aspects to it: understanding what large models are doing, because the large models have an advantage. Okay, they have a high when it's run a large amount of data, they have high levels of
Yes.
features out there
Yes.
already. They can improve
Yes.
upon it. So that's the advantage of a large model. But the large models, we do not know what's happening, how to understand what's happening. So that's where the
Yes.
interpretability comes. And when you have the interpretable knowledge of that this is what is happening in the large models, then you can add other adaptations to it. For example, I added an adaptation of extracting this and then applying another model, right? So this we're using the large model, but we're using where it's
Yes.
needed, not where it's like so not like
Yes.
randomly.
Yes.
That's
Yes.
what I
Yes.
mean,
Yes.
right?
I understand.
And most of the people out there who are not trained naturally and there is a hype around it, people are using random things. Okay, and that is what I think is not good for the society, for us from a safety
Yes.
perspective. So I will now move on to the small slides I have
Yes.
prepared for the
Yes.
viewers
Please.
about what I am
Yes.
working
Yes.
on. So here is a normal brain
Okay.
image. Um, these are the called the ventricles, the CSF, and this is the brain. Brain has two parts, mm, white matter and gray matter, as we all know. But let's not go into that. This is brain, and the dark region is the CSF, cerebrospinal fluid. And this is a diseased patient. The disease is named
Okay.
hydrocephalus. Okay, where uh, the duct through which the whole fluid flows, the CSF fluids into the brain ventricle, that gets
Okay.
blocked. Okay, there can be many reasons that gets blocked due to tumor, due to something else, infection, because infections can cause pus, which can inflate, which can cause inflammation and restrict the flow. So, and this usually, as you can see, this is what happens. The brain enlarges because the ventricle
Oh,
enlarges, and it's very painful for these
oh,
babies. It happens in the babies mostly. And let me show you some statistics. Around 0.4 million cases, pediatric
yes,
cases happen every single year. Quite a few of them from sub-Saharan Africa, and it's being researched that it's mainly due to, of course, there's a nutrition aspect to it, but also mainly due to certain
infection
bacteria and viruses like Penibacillus
oh,
bacteria, cytomegalovirus, which thrives in that
area.
environment. Okay, so that also happens, and as I said, that these infections caused by Penibacillus and cytomegalovirus, this is the most amount of cases that happens, 60% of the cases. And this is an image of uninfected patient's brain. Okay, so you can see how horrible it is. You cannot realize it's a brain at
Mm,
all. Okay, and again, it's, you can see this is also a diseased patient, but here you can see due to the infection it has become like this. This is separated out. These are pockets of fluid happening.
okay.
So my one of the goals is, can I use vision to solve this problem? But before I go into the problem, I will talk about something more about the image. So CT scans in babies poses a lot of cancer and radiation risk. Okay, because it has radiation. CT scan has radiation. So what is the alternative to that? So recently, Hyperfine Soup became the first low-field MRI scanner, which is approved by the FDA, which is a low-field MRI scanner, which has significantly low image quality. For example, this is a brain and this is its corresponding another brain, and you can see that how low quality the brain
Mm,
is on the right hand side. Okay, the left hand is a high quality brain, so it shows you that it is, uh, you know, it has a
the
low
image
quality.
quality is low because
But yeah,
that intensity of the illuminating beam is low.
yes, yeah. I mean, CT scan is usually 512 cross
Yeah.
512, but low field MRI is, it's 128 cross 130 something,
Okay.
132. So it's, you can see four times
Okay.
reduction at least, for sure. And there are many other things that are reduced. So number one question is that, can we detect infections using these low quality images? That's what I'm working on.
Yes.
But before I move into this whole idea of why we are trying to use images, doctors can usually do that, right? But essentially, this is, as you have seen, I am working with, there, most of the patients are from sub-Saharan Africa, and naturally, due to the resource constraint out there, how do you detect this? You take the fluid sample, send it to the lab, and then see whether it's infectious or not. Because if it is infectious, you can, you can give antibiotics to reduce it sufficient, and it can save a lot of lives out there. Okay, otherwise you have to do
Yes.
surgery. Okay, so this can, it's a time sensitive thing. So the faster we do, the better it is for the babies. So the question is, how can we do it? And naturally, you can see from the images that images have some distortion, some visual distortions that can be captured. So I'm working on such problems that, can we detect these visual distortions using AI and make it faster? Okay, and also make it interpretable. So, as I said, the goal is, you input an image and you predict whether it's infectious or non-infectious. And work has been done by our lab on CT scans. Okay, this is an example of a network. Again, it's domain enriched. I'm not going into what is happening in the network, but uh, this is on CT scan. But I'm working on low field
Okay.
MRI. But the second problem is also, can we guide the doctors to the infection location, which is also, as I said, interpretability. If we say it's infectious without telling that what are you getting out of the infection, it's not useful, right, to the doctors. Why will they believe me or the AI? So my goal is to make sure the doctors believe in it, and that's why they can use it on a large scale scenario. Okay. So this is an example for, you can see that this is called a class activation map, and you can see it's telling you that this is where the infection is. On the other hand, this is an uninterpretable model.
Okay.
This is uninterpretable and this is
Okay. My
interpretable.
interpretable means it is the result of the interpretable AI
Yes.
application.
So it's showing infection, and it's telling you also, these are the regions I see because of the why the infection is happening. So for example, here can be, this is a calcification, so here can be a calcification. Okay, you can see these are calcifications, so that's why calcifications are coming out. There are many other reasons. This can be inflammation out there. So, but the whole idea is it's telling you, but this is uninterpretable, it doesn't actually know, it's all over the place. Okay, so this is one example of interpretability. And as you said, for example, here is an example of different reasons for infection that are that are done by the doctors: calcified abscess, debris, loculations, necrosis. This is hemorrhage, and this is an interpretable model. And you can see that it's kind of looking into what we are actually trying to look, but the other models are not. Okay, so this is the state of the art model, the previous model, and this is now the better models out there, which are telling you that different reasons why it's looking into the case. Okay, so this is past work that is
Okay.
done. But the next main idea I want to tell this viewers out here is that how to get these guiding images. What is the mathematical understanding behind it? In simple language, I will make it very simple without making it
Okay.
complicated. That draw intuition. So let's say this is a linear model, a linear regression model, where you have two features x1 y1 x1 x2, and you have a prediction. For example, let's say you want to predict your basal metabolic rate based on height and
Okay.
weight. So the y is the basal metabolic rate, and you want to predict on x1, which is height, and x2, which is
Okay.
weight. Okay, which are the data you capture. Now w1 and w2 are data, are things to be
Okay.
learned. So from data points, let's say you get 100 patients data point, and you want to learn this w naught plus w1 plus w2 from the data points. So it's kind of turning out that BMR is equal to 0.7 plus 1.5 into height plus 7.6 into weight. I don't know, it's an example. Okay, and this is something, this 0 0.1 and 1.5 and 7.6, whatever I said, these three numbers are learned
Okay.
from the data. As data comes, different data gives different results, but it is kind of constant in some sense. So based on the data, you will get these different numbers. For different cultures, you can get different numbers. For Indian people, you can get different. For US people, you can get different. For Chinese people, you can get different. All of the world, different people have different segregations of different numbers. So this, let's consider this as an example. This is a model we are trying to build. So what do we mean by interpretability in this simple case? Once we understand what this simple case is, we will be able to scale it to images, right? The same idea. So now, what do we mean by simple method? Let's go to the very simple method. So one way to understand that which feature is the most important, x1, height or weight. What do we do to understand which feature is more important? It's like saying that which student in the class is the most important student, or which person in the team is the most important person in the team. So, Dr. Chaudhary, what do you think? How do you understand? What is the simple way that comes to your mind? Let's say there are 10 people in your
Okay.
team, and how do you understand which person is the most important?
By questioning them and taking their reactions, answers to the questions.
That's one way, I agree. But how do you know? Okay, okay, that's a good way. But I think this easiest way is to remove each person one by one, make them work over a period of 7 days. So let's say 70 days, you will get data and see that after removing each person from the team, the performance decreases, right? That's the one simple way, right? Without questioning. Okay. So similarly here also, you remove x1. If you want to understand the performance with x1, you need to remove x1. So you make it 0 and retrain the model and see how good it performs. You do it both for x1 and x2. Okay. We do it for both x1 and x2, and then see which, for which x1, like for which removal the performance drops the most. So let's say if after removing x2 the performance drops the most, that means x2 is more important than x1,
Yes.
right? So just like after removing, let's say, Ajit from the team or Sneha from the team, the performance dropped the most. That means Ajit or Sneha is the most important person in the team. So this is one way. This is I call the minimalist method. Now, if you observe what exactly we are doing here, we are actually perturbing y, and we are also perturbing x a bit. And we are trying to understand that for any x and y value, what, so in the previous case we were only looking for x is equal to 0, but the x can have many values, right? So how do you know for which x value the change is the best? So this is kind of the derivative situation. You want to understand for current x, you perturb it a bit and see how the y also
Yes.
changes. If the y changes a lot and decreases, that means it's more important, right? So it's kind of the derivative of
Yes.
it,
Yes.
right? Which is the derivative as you can see on the
Yes.
screen. And if you look, this w1 and w2 are nothing but the derivatives of y with x1 and x2.
Yes.
So in some way, this w1s and w2s are the measurements. I will come to this later on also. But let's see an example how we can look, how we can extend this idea of the minimalist to the images. So what you do is that in images, this is called occlusion sensitivity. You can make one portion of the part of the image zero, a large
Okay.
part. Let's say image is 512 cross 512, and you remove a portion of 10
Okay.
cross 10 all
Okay.
over the image. Okay, let's say you get 50 different patches, right? Now, after if each of those, so you should train a model. The model training is good. Now you remove each of these patches and see the model performance. Okay. Now let's say you are predicting brain tumor or not. One of those patches will be on brain
Okay.
tumor. So in that case, the model will be
Okay.
reconfused. So they will understand. Okay, that is where the most important information lies. Just the same as the previous one, right? So this is called occlusion sensitivity, and you can see that the results of this is like this occlusion sensitivity. It's, if you remove this part, you can see that the red tells you that this is the most important
Okay.
part, okay, which is giving you the information. This is for COVID-19
Okay.
detection. Does it make sense,
Yes.
Dr.
Yes.
Chaudhary?
Yes. Gives.
It's just like you're removing the feature, and in image the feature is a patch you are defining like this, the simplest way. Now why we're not doing pixel by pixel? Because the information lies in a
Larger area.
larger patch in the
Yes.
image. Yes, so that's why we are doing a larger patch.
Yes.
Now, how big is the size of the patch? That is a parameter you need to experiment with and see. Okay, this is called occlusion sensitivity. Now, I will call this method another method, which I call the NART because it involves more mathematics. But it's exactly the previous one. The previous one, we were looking at the change for x is equal to 0. Now, we can look at the change for any
Okay.
x, right? And if you do the derivative of y with x, you will get w. In this case, w1 or w2. So the w1 and w2 are actually telling you the importance of
X1.
x1 and x2
Yes.
respectively. So that's also one of the way, right? So the derivative is also one of the ways to check that, and that is what a fundamental um, aspects behind this class activation map or gradient class activation map, okay, where we use the gradients to calculate the importance of the images, of which region of the image is important. Okay, but the basic idea is this: we want to see the changes of the weights, changes of the, we are actually looking into the weights of the neural network, which are nothing but telling you that if x has changed a bit, how much has y changed. Okay, so this is what I want to tell you. So this is a basic thing you need to know, and this is exactly what is scaled in the images also, and similarly it is done in the language also. There are other methods to this, where they have defined so much mathematics of what do we mean by this change in features. Okay, and you can read about this online, but the basic things, the foundations remain the same. Okay, it just becomes more complex for solving more abstract complicated problems. So another example is for this nerd type thing is that previously it was asking that where is human.
Human.
So it was not, it was probably giving here, but after making it better you can see, or rather it was giving in on one single person, but after making it better it was actually focusing on better, after improving the gradient method or that interpretability method, it can focus on both the persons together. Okay, so for example here it is focusing on the hand of this person, but here it's focusing on the face of the two persons. Okay, so this is what we mean by
Okay.
interpretability. We want to understand how the model is doing. So here are a few books where uh, you can learn about deep learning, and it's, this was the book I was talking about by Terry
Okay.
Sesnowski. about deep learning revolution. And this is beautiful. This is something, if you read, yeah, essentially deep learning is nothing but understanding the artificial, like training and understanding the artificial neural networks that we have built by hands. um, yeah, so that's all about my whatever I want to share today to our
The
viewers.
simple uh, snapshot of your research work.
Yeah, it's simple. It's a very boiled down version.
Yes.
Like, what is my core theme? To, if I want to tell you in simple language, it's my core goal is to help doctors use interpretable AI methods and believe in AI. Okay, it's not like there's the variance is large in the community right now. I want to make them understand that it's actually more interpretable than you think. It can be made more interpretable than you think. Okay, it just do not have to be off the shelf and apply. It has more interpretations, and you can build that for you.
Thank you
Yeah.
for explaining in a very simple way. And we have not planned, and very quickly you adopted and you presented the method and the meaning of interpretable AI and also the essence of your current research. So,
Absolutely.
if you want to tell anything about why you have chosen AI or studying neural network, anything like why you have chosen this field?
Sure. So I am from, okay. So I didn't mention this while introducing
Like say
myself. I
from your
also
bachelor's and when you have completed your master. So how you have come to neural network means because the institute is giving you the choice or you have any other reason?
that's a very good question. Yeah, many people ask this question in a different way. Why have we moved from statistics to electrical engineering? So I have a bachelor's and master's in
Yes,
statistics from ISI
yes.
Calcutta, and it's a place of ISI
Statistics, yes.
statistics and
Maths,
math
yes,
lovers. So, and statistics was built by PC Mohan Lewis there
yes,
in that, with the help of
yes.
Rabindranath Tagore, uh, in that place. Okay, that's a living place there. Anyways, um, so in statistics it was always about interpretability. Okay, under the hood we wanted to understand the distribution. Data is random, right? Data is random, and to mathematically model data we need probability. Okay, we need to somehow understand how our human minds are funny. um, we try to find order in disorder. That's good, but in that process we overdo it. But probability is a very good tool to mathematically model disorder. And when you are mathematically modeling something, of course introduce some order into it. And the probability helps you mathematically model this uncertainty out there. And naturally, when you have mathematical models, there's certain laws and rules and structure that helps you model the real world scenario better. Uh, so there everything happens by random variables. Okay. uh, let's say an image is can be described as a random variable over r to the power m cross n. Okay, it's a random matrix out of which there is order out there. If you take a random such a matrix, the image will look like a noise, but there is order out there. So in statistics what we are being taught uh, is mostly about tabular data. Okay, and the whole of statistics is about finding interpretations. Otherwise, how will you use that? How will you use that to solve government problems? That was one of the Mohanlawish's
Yes,
main goal,
yes.
right? To solve government problems, to use statistics to understand the flow of the rivers, to build dams. And that has been the core essence of statistics in the whole world. Statistics was built by biologists, genetists. Okay, Ronald Fisher was, yeah, I mean, was a biologist himself, or geneticist himself, I'm sorry. So it is inspired by science out there. Okay, but it was also very mathematically heavy that cannot be scaled out there. For example, since now to use this probability in this real scenario, you have to simulate, and you have to use Bayesian techniques. Okay, simulation, Monte Carlo simulation. Now that is really not scalable out there. Okay, that is not possible with that's that kind of complexity fails in high dimensional spaces. Okay, an image is a high dimensional space. A CT scan is 512 cross 512. That's 2 to the power 18. Okay, 512 is 2 to the power 9, and it's 2 to the power 18. And naturally, statistical methods will fail, and statistics was not built for such high dimensional things. It's not really, yeah, it's not really built for this natural thing. If you observe that human beings used to observe these natural things, this natural data, and then write down numerical data from that, and then use statistics on that. And on the other hand side, signal processing was only doing in this raw data, and Sierra was one of them who worked on bridging those two at actually Penn State, where I'm studying
Okay.
now. He's passed away a few years ago, um, on statistical signal processing, okay, to incorporate them. So the work has been going on for a long time, but um, so my goal was all my 5 years of education at in ISI. I have worked in mostly uh, tabular data. Okay, I wanted to understand how to deal with real data out there, and it was not easy at all. It was not easy. And that's why I wanted to understand. I did ecological statistics, my master's project, and wanted to understand what the statistical um, has to offer in the applied field. And then with the help of my professors at ISI, I got an opportunity at Penn State. I also got other statistics opportunities, statistics PhD opportunities from other places too. But then discussing with Professor Digonda Mukherjee, he has been my guide of PhD, of how to apply for PhD and whether I should apply or not based on my direction. And I discussed with him, and I realized that pains. I mean, based on my goal, I realized that uh, the working with images will be a really good option. And I just stepped into the darkness because I had no idea. I had zero idea about images and signal processing. Anyways, after coming here, my current advisor, so Professor Dipti Prasad Mukherjee, has helped me, to connect with my current professor at Penn State. Uh, and after coming here, I have to take undergraduate classes in computer
Okay.
vision and
Okay.
signal processing. So from that I got to know about that. So that was, and I have to learn linear controls and system, all the so the good thing is that ISI has really taught me foundations of mathematics, statistics, and probability well, so I could
Switch very easily
do.
to computer vision.
Yeah, yeah, because it's all
Applied
applied
mathematics.
mathematics
Yes.
probabilities. So for anyone out there, if you think your foundation is really good and if you want to change into AI, a good foundation in math, probability,
Six
statistics, or physics
is a
also,
must.
anything, yeah, is a must, and it will help you really understand well. For example, when I first learned computer vision, in the first few classes I learned about edge detection. It is nothing but a derivative of
Yes.
the
Yes.
image, a
Yes.
discrete
Yes.
derivative of an image. So having a calculus understanding really helps you quickly catch
Yes.
that, right? So yeah, so that's how it helped me, and I have to work a lot of hard. Okay, I couldn't do research in the first 2 years because I have to learn myself what the whole, and my advisor has been kind enough to give me that
Opportunity.
opportunity,
Yes.
current
For
advisor,
learning this. Yes.
to learn first, and he believed in me. Yeah, ISI tagged, and of course
That
that
help. Yes.
scores I
Yes.
had, and of course
And just
Professor
curious,
Mukherjee's.
what was your the title of say bachelor's or master's thesis?
Oh, I didn't have a thesis. I didn't have the score to have a
No, I
thesis.
mean in
The required
ISI
amount of
there is no
grade.
essential. I mean requirement.
No, you have to do a project or a
Okay. Okay.
thesis. Yeah,
Project. What was the title of your project of your master's?
it was about predicting. So ISI has a lot of ponds out there. Okay,
Yes. Yes.
so The ecology team, Shobhujaji Bhattacharya, he was my guide then. So there's a pond, and in the pond they divided into four sections, 2 cross 2, and on one side there was trees, on the other side there were no trees, A, B, C, D, and there was a fish. I forgot the fish's name. So what they're measuring, they're using data to understand that how does, so for example, due to the shade of the
The shadow of the
tree
trees,
from this,
yes.
yeah, the phytoplanktons grew accordingly in that four
Yes,
regions,
yes.
different regions. And the beauty of this growth models of fish, I wanted to study, like the whole thing was about studying fish growth in those four regions. And what happened was, if you have more phytoplanktons, if you have, it's like, it's a prey predator model kind of thing. So let's say if you have more food and less people, it will grow. But if you have less food and more people, it will again come down because there is less food. So this growth curve has kind of asymptotic
Okay.
structure. Okay, after a constant, the population become constant. A certain population, after that it decreases, after or before that it increases. Okay, so there is a sweet spot. So it was about understanding and building statistical models to, so now this growth curves, logistic growth curves, and all these curves have parameters A and B. Okay, just like the logistic model, it's just parameters, same actually mathematical equation, but different scenario. This is the beauty of mathematics. um, these are the parameters A and B. um, and the whole goal was to estimate those parameters on the data. Okay, because those parameters tell you a lot about the growth structure, that how it will go, which are the sweet spot, and yeah, A and B will tell you which is the sweet population spot. So that will help the ecologist to grow till that point of time and then stop, right? So that will help the ecologist in a lot of beautiful way. So this is the beauty. You can actually apply statistics to anywhere. And at ISI there was also language places
Departments,
where they
yes.
used, yeah. So statistics, and hence AI is available, and I think it's a future. I mean, everyone, it's a future. There is no way concern about that. It's just about how you make it safer.
Yes. How you make it safer and how you don't actually go somewhere which is unethical.
Yeah, yeah,
And
yeah.
ethical use of
Um,
AI is the most important thing.
yes, the issue is that ethics differ from
Of
people to
course, of
people.
course. Directly,
Yeah.
directly if
So
it affects the humanity, then it is unethical. That is a concept, very easy concept.
yeah, and I think that it should start from the bottom up rather than top bottom approach, because people are up there, their job is different. Their job is to run the
Yes,
country, okay, nations. Their job is not to understand
yes,
AI. Our job is to
yes, yes,
understand AI, and we should do our duty. They should
yes.
do their duty, and then we should make some results, talk to them, try our best. After a few decades, it will be possible. We have to just hold on to our belief that it will be possible.
Excellent, Srijit, and thank you so much for answering the questions. I mean, novice questions, of course. And so in ISI, your input was the image data. That pond, no,
No,
no.
no, no,
Then
no, no.
how
Tabular data.
tabular data, but how that they prepared the tabular data of the pond. That is interesting.
So they are experimental ecologists, right? So you should go there and find how much fish has grown. So okay, that's a very good question. So they have fish tags,
Okay.
just like tags. So they have fish tags, and they use random sampling. So that's where the sampling comes. They have random sampling to understand how many fishes have
Oh,
grown. Okay, you can
so
actually
it is
measure the
actually
amount of
counting.
fish.
You can say basic counting. Like these are,
Um,
but how
it's
do they do
statistical
the
counting in
counting
some
by
sense.
without taking a photograph or without say watching? So
Yeah.
when my thing is
So
that
let
is
me
a
give you an
visual
example.
data and then transforming into tabular
No, no, it's
data.
not a visual
Eh?
data.
No.
Let me give you a simple example. Let's say you want to estimate the number of fishes in a pond. Okay, and what you do is that instead of those four, you just focus on one place, one of those, and you pick up a fish. You see it's marked or not. If it's not marked, mark it, and then pick up a fish, marked or not, then do it. And let's say you understand over 10 days that there are around 15 fishes there, and it's growing at this rate. Now you multiply by 4 to extend that to it's like generalized to that. So that's how they used to. This is a specific name of sampling. I'm sorry, I forgot. I have lost in touch with this all these nomenclatures, but I remember the basic idea. So this is how
Okay.
they. So they don't actually go out there and measure every fish. They have an estimate of
Okay.
growth, because the growth is
Okay.
relative, right? Like, yeah, it's like an estimate is also
Okay. Okay.
work.
Okay. Okay. So thank you for extending it, and we will maybe, if you agree, we will plan something more focused and in a planned way in the future episode. And
Sure,
sometimes
absolutely.
maybe we
We
can
can talk
make
about
it
that.
uh, in Bangla also. Say
Oh,
for
absolutely. I would love
say
that.
other platform. Okay.
I would
Because
love
some
that.
people have, some
Whatever.
people
If you,
don't do it in
I
Bangla.
only know two language
Yes.
well, Bangla and
Yes.
English. I'm not comfortable in
No,
Hindi
I'm
though.
also not.
I can understand speak.
Okay, thank you so much. We'll connect again. And
Yeah. So do the viewers have
no,
any question? I
here
don't know.
they don't, because in the chat section there is no question. But the good,
Okay.
it is a bad thing. But many people clicked join, but they don't see it even questioning. But it is recorded in both
Okay.
on LinkedIn
Super.
and YouTube. All live are recorded, so later people can watch it and get some information, and maybe some comments will, some people may write comments. So
Oh, sure,
but
sure.
it is not
Absolutely.
an,
Got it.
a community, it is a general community. So and also our followers are not from very focused area of, say, academics and other things, although they are, but
Sure.
they don't have probably the patience or patience of concentrating and going through life.
No, no.
Yes,
Also, I
but
mean,
it is recorded, and
people are
yes, it
busy
is
and they have their
recorded,
own life
and
to
so
think about.
later we can again share it, and we can have this and watch it. And some people will,
So,
please.
will it be posted on some YouTube or something?
It is going live. It is going live to LinkedIn and YouTube simultaneously. So it is there. It is there
Okay.
in the
Okay.
YouTube,
Super.
in the live section. Yes.
Okay. I will take the link and
Yes.
share
Yes.
tomorrow
Okay.
probably.
So thank you so
Yeah.
much. We'll catch again, and we can end the stream here, and we can say goodbye for now. Thank you.
Yeah.
See you
Goodbye.
again.